Ever wondered how your computer accesses files from different storage devices? Today, we're going to delve into the process of file system mounting. This is a method used by your operating system to make various storage resources accessible in a unified directory structure. Now, you might be wondering, what's a directory structure? Think of it as a tree with branches representing different paths to your files. The point where this tree attaches a new branch, a new file system, is called a mount point. Once a file system is mounted, it's as if its files and directories have always been part of this tree, making them easily accessible. This is the beauty of file system mounting. It seamlessly integrates multiple file systems, which can reside on different physical devices, into a single cohesive system. By the end of this video, you'll have a clear understanding of how file system mounting works and why it is crucial for your computer's operation. So, when exactly is file system mounting used in our daily computing tasks? You might be surprised to know that it's more often than you'd think. One common scenario is when you're accessing external storage. If you've ever plugged in a USB drive or an external hard drive, your computer has performed a mounting operation. It's during this process that your operating system recognizes the file system on your external device and makes it accessible through its own directory structure. In essence, it's like your computer is extending a warm welcome to the newcomer, integrating it into its existing ecosystem. Now let's talk about partition management. If your system has multiple disk partitions, mounting is used to bring them all together under one roof. Each partition can be thought of as a separate house with its own unique set of files. Mounting is the process that brings these houses together to form a single, unified neighborhood. Moving on, we have network file systems. If you've ever accessed files shared over a network, you've likely interacted with a mounted file system. For instance, Unix and Linux systems use something called the Network File System, or NFS, while Windows systems use the Common Internet File System, or CIFS. These systems allow for remote access to files and, you guessed it, they use mounting to make this possible. Finally, let's touch on virtual file systems. These are special types of file systems that don't correspond to actual files on a disk. Instead, they provide a way to interact with system-level information. One example is the /proc file system in Linux, which is mounted at system startup and provides a window into the kernel's inner workings. As you can see, file system mounting is a versatile process that enables us to interact with different storage resources seamlessly. Whether it's a USB drive, a disk partition, a network share, or a virtual file system, mounting plays a crucial role in how we access and manage our data. So the next time you plug in that USB drive or access a network share, remember that mounting is working behind the scenes to make it all possible. Now that we know when file system mounting is used, let's go through the step-by-step process. Our first step is identifying the file system. This could be anything from a disk partition, an external drive, or a network location. It's essential to know what we're dealing with because different file systems may require different handling protocols. The next step is choosing a mount point. This is the directory where the file system will be attached. It's like picking a meeting point, a place where the contents of your file system will be made accessible. You could use an existing directory or create a new one just for this purpose. Once you've chosen your mount point, it's time to mount the file system. If you're a Unix or Linux user, you'll use the mount command. If you're a Windows user, your system typically handles this automatically for removable drives. It's like flipping a switch and suddenly there's a bridge connecting your file system to the rest of your directory structure. Now that your file system is mounted, you can access its contents through the mount point. It's as if it was always a part of your main file system. You can open files, save changes, and explore directories, all from within your main operating system environment. But what happens when you're done? That's where our final step comes in, unmounting the file system. This is the process of detaching the file system from the mount point, effectively removing its integration with your directory structure. In Unix or Linux, you would use the mount command. In Windows, you can do this through the graphical interface. Why is unmounting so important? Well, imagine you're editing a document on an external drive, and you suddenly unplug it without unmounting. You could lose your changes or even worse, corrupt the file. So always remember to unmount your file systems before removing the device. But what if I forget, you might ask? Well, some operating systems have safeguards in place. For example, in many versions of Windows, if you try to remove a device that's in use, you'll get a warning message. but it's always best to get into the habit of unmounting devices properly to ensure your data stays safe. So there you have it. From identifying the file system to choosing a mount point, mounting, accessing, and finally unmounting the file system, that's the whole process in a nutshell. It might seem a bit technical, but it's a fundamental part of how our computers manage and access data. And that's how your computer mounts a file system. Remember, always ensure you unmount any external storage devices before removal to prevent data loss. Different operating systems handle file system mounting in slightly different ways. The process of mounting a file system can be as straightforward as plugging in a USB drive, or as complex as configuring network file systems. But no matter the complexity, the core objective remains the same: to make a file system accessible within the broader directory structure. Let's take a look at how Unix and Linux handle this task. These operating systems, known for their robustness and flexibility, give you a great deal of control over how and when file systems are mounted. The key tool here is the mount command. This command allows you to specify the file system to be mounted, along with its mount point. It's as simple as typing mount, followed by the device and the directory where you want it to appear. But what about automating the process? That's where the /etc/fstab file comes into play. This configuration file defines which file systems should be automatically mounted at system startup. By editing this file, you can ensure that certain file systems are always ready for use the moment you boot up your system. On the other side of the spectrum, we have Windows. This operating system typically handles the mounting of file systems automatically, particularly when it comes to removable drives. When you plug in a USB drive, for example, Windows automatically mounts the drive's file system and assigns it a drive letter. This drive letter serves as the mount point, allowing you to access the drive's contents through the Windows Explorer. Of course, Windows also provides options for more advanced mounting scenarios, such as network drives or virtual hard disks. These options can be accessed through the Disk Management utility or the Mountfol command line tool. So whether you're using Unix, Linux, or Windows, your operating system has a method in place to handle file system mounting. These methods may vary, but they all aim to provide seamless access to your files and directories, no matter where they're physically located. Let's quickly recap what we've learned about file system mounting. This crucial process, integral to operating systems, refers to making a file system accessible by attaching it to a specific point in the directory structure, known as a mount point. Once a file system is mounted, its files and directories become part of the broader directory structure, facilitating interactions as though they were part of the main file system. File system mounting helps an operating system organize various storage resources into a unified directory structure, enabling the integration of multiple file systems, potentially located on different physical devices, into a single coherent system. The directory where a new file system is attached is the mount point, and accessing it provides access to the contents of the newly mounted file system. We've also looked at when mounting is used. External storage devices like USB drives or network storage devices can be mounted, making their contents accessible through the operating system's directory structure. It's also used in managing systems with multiple disk partitions, integrating them into a single directory structure. Network file systems such as Unix Linux's network file system or Windows Common Internet File System can be mounted to enable remote access to files. Some virtual file systems like Linux's /proc provide a way to interact with system-level information. The mounting process itself involves identifying the file system to be mounted, choosing a mount point, mounting the file system using a system call or command, accessing the mounted file system, and unmounting the file system when access is no longer needed or before removing a device. Mounting varies across operating systems. In Unix Linux, it's a fundamental part of the operating system, using the mount command to mount file systems, and configuring the /etc/fstab file to define file systems that should be automatically mounted at startup. And that wraps up our discussion on file system mounting. Next time you plug in an external drive or access a network file system, remember the processes happening behind the scenes to make it all possible. Thanks for watching.